You ever stop and think about what's actually holding our digital world together? When you shop online or ask your smart assistant a question, there is some seriously heavy-duty engineering making sure it all just works. Well, today we're going to pull back the curtain on one of the most critical pieces of that infrastructure, Amazon's DynamoDB.
Take a look at this number, 89.2 million. Any guesses what that is? That, my friends, was the peak number of requests hitting DynamoDB every single second during one of Amazon's Prime Day events. I mean, that's not per day, not per hour, that's per second. Just insane.
So that leads us to the big question, right? How in the world do you build a database that doesn't just buckle and crash under that kind of insane pressure? Not just for one crazy shopping day, but all day, every day, for millions of different applications at the same time.
To really get our heads around how they pulled this off, we need to look at the three core challenges that DynamoDB was engineered from the ground up to solve: insane performance, bulletproof durability, and constant, always-on availability.
So what is DynamoDB really? Well, the official definition is a fully managed NoSQL cloud database. Let's break that down. NoSQL just means it's super flexible and not stuck in the rigid rows and columns of old-school databases. Fully managed is huge because it means developers don't have to worry about running it. But the magic words are consistent performance at any scale. That's the promise, and it's what powers almost everything at Amazon. We're talking Alexa, the entire Amazon.com shopping experience, all of their fulfillment centers, the whole shebang.
And you got to understand, a beast like this wasn't built overnight. It's been a constant evolution. You can see here, since it launched way back in 2012, they've been adding major new capabilities, constantly learning and adapting to handle more and more scale.
All right, let's tackle that first big challenge, performance. How do you make sure every single request is lightning fast and predictable? It doesn't matter if you're one person or 100 million people hitting it at once, the experience has to be the same.
You see, in a perfect world, all the traffic coming into your database would be spread out perfectly evenly, right? Nice and predictable. But reality? Nah, reality is messy. A product goes viral, a celebrity mentions something, and suddenly you get these intense hotspots where a massive amount of traffic just hammers one tiny piece of the database, threatening to bring the whole thing to its knees.
So how did they solve this problem? It wasn't one single fix, it was an evolution. First, they tried bursting, basically using some spare capacity for short spikes. Then they got smarter with adaptive capacity, which could automatically shuffle resources over to where the heat was. The next big jump was something called global admission control, which is kind of like a master traffic cop for the whole system. And all of that learning eventually led to the holy grail, on-demand tables. The system just scales automatically. You don't even have to think about it.
And this quote right here, it just sums up the whole philosophy. The goal wasn't just to solve a technical problem, it was to make that solution completely disappear for developers. Think about it. You no longer have to guess or predict your traffic, the system just handles whatever you throw at it. That is a game changer.
Okay, so performance is handled. The database is fast. Great. But what about the data itself? This brings us to the second, and you could argue the most important rule of any database. You can never, ever lose data. Once it's written, it has to be safe, forever.
To do this, DynamoDB has this awesome defense-in-depth strategy. First, before any change is even committed, it's written down in a write-ahead log. Think of it like a super secure journal of every single transaction. Then that journal gets copied to Amazon S3 for, ultimate durability. Second, there's a process called a scrub that's always running in the background, constantly checking for any silent data corruption or bit rot. And finally, and this is seriously nerdy and cool, they use something called formal methods. They literally use mathematics to prove that their core data replication algorithms are correct, catching bugs before they're even written into code.
Now check this out. This is how they handle a server just dying. On the left, you see a full copy of the data. If that machine fails, rebuilding it from scratch could take a while. So instead, DynamoDB instantly, and I mean instantly, spins up a super lightweight log replica like you see on the right. This takes just a few seconds, and it makes sure the database always has enough copies to stay safe while the full recovery happens quietly in the background. It's so clever.
Okay, so it's fast, it's durable, the final piece of the puzzle is availability. How do you make sure the database is just always on, 24/7, 365? No downtime for failures, no downtime for software updates. Never.
This number is the promise, 99.999%. We see a lot of 9s in tech, but let's put this one in perspective. It means the system is designed for less than 32 seconds of downtime in an entire year. 32 seconds. That is an incredibly high bar to clear.
So how do they even get close to that? The main strategy is just massive physical redundancy. Your data isn't just sitting on one computer in one building. As you can see in this diagram, it's replicated across multiple completely separate data centers called availability zones. So if a whole building loses power or has a network problem, who cares? The system just keeps on chugging along using the other copies, and your app never even notices.
But they take it even one step further, with the design principle they call static stability. This is brilliant. It means DynamoDB is built to survive even when the other services it relies on are having a bad day. For example, it caches things like permissions. So, if the central authentication service goes down, DynamoDB can keep on working with the permissions it already knows about, preventing one small problem from causing a massive, cascading domino effect.
So after more than a decade of running this thing at a scale that's hard to even comprehend, what are the big takeaways? What can we learn from this journey?
It really boils down to a few key principles. First, you have to build for how your customers actually use your service, not how you think they should. Second, never trust your data. Verify it constantly. Silent corruption is real. Third, prove your system is correct with every tool you've got, even if that tool is advanced mathematics. And finally, and this one's huge, design for predictability. A system that's stable and consistent is way better than one that's a tiny bit faster but completely unpredictable.
And this right here, this is the proof in the pudding. These are standard industry benchmarks, and they show that predictability in action. What you're looking at is how long a request takes. Now watch what happens. The workload scales up by a factor of 10, from 100,000 to 1,000,000 operations a second. But look at the bars. They barely move. The performance stays almost perfectly flat. That is the holy grail. It means no matter how much you throw at it, it just works.
The story of DynamoDB is just incredible. It shows you the level of deep thinking and relentless engineering it takes to solve today's problems of scale. And it really just leaves you with one big question to chew on. As our digital lives create more and more data, what's the next great engineering mountain that we're all going to have to climb?